call me if there's any questions. You don't have to use the formulas. I put them out there in case you happen to like the formulas. I, again, think it's easier without the formulas. Just gauge where you're going. If you're opening to the right, then P is going to definitely be positive. It's going to show you the positive P. If it's opening to the left, that's where your negative comes in. Find your directrix and your focus. Your directrix has to be aligned. You have to give this to me as an equation of a line. So make sure I get a line for that. Intercepts, and I told you on your homework, if you have no real intercepts, you don't have to do that part on the homework. But on the test, yes, you have to show it to me. But on the homework, if you obviously see there's no y-intercepts, just say no real y-intercepts. It's always good to put that in there because it does help you. It does help you check. You know, it does help you see if you got it right, if you're doing the right thing. Again, an x squared is positive, it's opening up. You want to get rid of that 20 out of there. If you want to set that equal to 4p. Don't forget it's 4p, not p. Good. Intercepts, no x-intercept, no real x-intercepts. Okay. Stop me if you have any questions. I just thought this would kind of tie up all the parabolas before we move on to ellipses and hyperbolas. Again, you had to complete the square, get the square and the x by itself. Complete that square. And this is where your intercept actually helps you, your x-intercept and your y-intercept, especially the y, will help you see how wide this is. Because you don't want to put it in front of that if it's going to cross over it. So you might want to do your intercepts before you sketch your graph. Good. Again, you're completing the square. And it doesn't matter which one you go to, whichever one you like to use to find your intercepts. Use whichever one's easier. Questions at all? These are working pretty good for you? Remember the first day you hated that format, and it's not so bad, right? It really helps you graph this. Find the equation. You probably didn't have to do the intercepts on this, but I just threw those in there. Okay. And the last one, this is the last one. Find this equation. An ellipse is a set of all points, x and y, on your ellipse, where the sum of the distance from any two fixed foci points is always constant. And your center of your ellipse will fall in here, right between the two foci. Figure that's the center. And anytime you draw something that goes like this, off of any of these, their sum will always be constant. And that's by definition of ellipse. We work on finding the center. We work on, it's like finding the center of your circle. It almost looks like the center of your circle, doesn't it? X minus h squared plus y minus k squared equals r squared. So if you had started like this, here's your circle. There's the equation of your circle. So to get an ellipse, we would get rid of this guy. Divide everybody by r squared. And it's set to 1. So a circle is a special kind of ellipse. It will be equal, so you'll see we can do a circle as an ellipse also. And that's where we kind of get our format from. Our foci we find also through we use this formula to help us find the distance C between the center and the foci. We're also looking for vertices. You have a major axis, you have a minor axis, meaning this. If here's my, excuse me, if here's my axis, if this is my ellipse, your major axis is where it's longer. So technically we translate this axis. We move this axis over. So here's your center, let's say. We move this axis over and we make an axis here. We just translate your axis. Yes? Oh, I'll talk about that in a second. So your major axis this time is your y-axis, the one where it's longer. So this guy would be your major axis. Off of the major axis, we have vertices. Off of the minor axis, we have covertices, and you'll see why we use those in a minute. And then your foci will fall along your major axis. Now, Rohan said, what if it goes the other way? Oh, we won't have one of those. We'll either have it x-axis, y-axis. Yeah. We're just basically introducing you to this. We don't do a lot with ellipses. Actually, when we do parametrics, you'll see how we convert them to ellipses. So it has a cool thing that we'll be doing. So this time, the longer one is your x-axis. This would be your major. So your foci would fall in here, and your vertices would be off of here. And your covertices would be off of here. Now, what drives this, if you notice, there's a plus sign here, just like your circle. And in your circle, I could write this. Is that wrong? No, because addition says commutative property, I could add it any which way. So sometimes you have to be careful because they will switch these. Because it's an addition, it doesn't matter. What drives this, which makes A, is the major axis. Whichever one is the larger number. So if this is our major axis, then it's going to be sitting under the x squared. If this is our major axis, it's going to be sitting under the y squared. The larger denominator is always A. It's always your major. Because it's an addition, there's no other way to tell. A hyperbola, we know the one that comes first is to subtract. And subtract makes a difference, but addition does not make a difference. Most of the time you're going to see them set up with the major one coming first, but they can absolutely switch that because it's addition. So we're going to work on some of these and show you where these come from. This probably, well, obviously you never did an ellipse at all, so the C is probably going to be the new part, the focus. And, you know, once you get this started, you're going to see it's not so bad. But just so that you get a feel for where this is going. Now, we're going to take this standard equation and we're going to put it into the equation of an ellipse. So if you notice your ellipse had an x and y squared and over a and b equal to 1. So we're going to get the x's together and complete the square. We're going to get the y's together and complete the square. So let's rewrite this to put your x's together, leave a space to complete that square. Then put your y's together, leave a space, and we're going to complete that square. We're going to move 9 to the other side. Get your constant on the other side. Okay. Now, the x has no problems because the coefficient of x squared is 1. So what's half of 6? 3. And what's 3 squared? 9. So we add 9, we add 9. This guy's going to give us a little trouble. So what do we have to do first? Factor. We have to factor out the 4. Okay. and we're going to equal the same thing over there. So now, what's half of negative 2? Negative 1. Keep your 4. And what's 1 squared? 1. But when we move it to the other side, what do we have to do? We have to get it out of this parentheses. So we have to multiply and put 4 here. So here's our equation so far. The 9's come out, and we're equal to 4. Now, it almost looks like a circle, right? The only thing that makes it not look like a circle is this guy right here. If that guy was missing, wouldn't it look like a circle?
Sure would.
Because it's there, and the coefficients are not the same, that's how you know it's an ellipse. The ellipse always has the plus. It looks just like the circle, except for the coefficients are not the same. A positive 4. Yeah, I'm adding it to the other side, not the same side. I put it on the other side. You want to keep all your numbers on the other side. Okay? All right, now, our goal is to get it set to 1. So we're going to divide everybody by 4. We want to keep this fraction. So x plus 3 squared over 4. What happens to this 4? Cancels. Just keep this over 1 equals 1. This is the format for your ellipse. So the larger one in this case is 4. This gets the a squared. This gets the b squared. So who's ever over the larger number is the major axis. Not who comes first. Whoever has the larger number is the major axis. So the major axis in this case is the x. You find the vertex of the center the same way you found your vertex, the same way you find your center of a circle. So let's find your center of this guy. So what's the center? Negative 3, 1. Same way you'd find your vertex with the h and k, same way you find your center of a circle, h and k. Your center is always going to be h and k. Now you really can't use your calculator. You really just have to sketch. So we're going to go like this. We're going to set up A equals B equals C equals. Notice they're squared. An easy way to remember it is this way. It's squared on the top. This is also squared. So what's the square root of 4? 2. So A is 2. What's the square root of 1? 1. Now, we had that little equation. C squared equals A squared minus B squared. This will give you C. So we're 4. A squared is 4. B squared is 1. So C squared is 3. So C is radical 3. So we're going to start with your center, and we're going to say negative 3, 1. This is where your center goes. So technically you translated this axis. It's easy to work with if you kind of make your axis like this, because this is where you're going to go off your points. Now, A is the major axis. So going X is where I'm going to be more oblong. I have to go 2 units to the right and 2 units to the left. If you take this one's negative 3. So if I go 2 units, I'm over here, and 2 units, I'm over here. This is a vertex. So what's the coordinates of your vertex? Use your center and move 2 to the left and move 2 to the right. So here's my center. If I move 2 to the right, what point am I at? Negative 1, 1. If I move 2 to the left, what point am I at? Negative 5, 1. There's my vertex. My vertices. Because I have 2, they're vertices. Excuse me. So now I'm doing the y. The y is moving along the y-axis, your translated y-axis. The value of b is 1. So you're moving down 1, you're moving up 1. These are called your covertices. Okay, so use your center and find your vertex points. So if I'm moving just the y, what's one of them called? Negative 3, 2. And what's the other one? Negative 3, 0. So we found our vertices. This is all we need to make your ellipse. Here's your ellipse. You have to bear with me because my board is always off. Yes.
For the 5, what is a negative 5 one or is it just 5 one?
It's a negative. There's a little negative out there. Sorry. The right side of my board is not as cooperative as my left side. I think it's just not balanced or something. Okay, so now we have to find your foci points. Your foci are going to sit on your major axis. They're both going to be equal distance away from your center. And the value of how far they are is c. And we found c to be radical 3. Now, because it's a radical, you can leave it as a plus or minus. So if you take your x value, negative 3, plus or minus radical 3, this will give you your foci. But we can't do anything with that. We're going to find your foci, which fall on your major axis. This guy is your major axis, because under x is the larger one. So off of the center, negative 3, it's going to move radical 3 to the left, radical 3 to the right.
Oh, okay.
So since we really can't simplify that any further, you can leave it like that.
You don't have to separate the plus and minus.
No,
Put it close to
no, because in this case you're kind of stuck. If you want to, you can. I don't have a problem if you want to separate that, but there's nothing else to do with this. You can absolutely leave it like that. If that's, you know.
I just didn't know
Yeah.
if that's what you wanted.
Yeah, because it's a radical, we really can't reduce it any further. It just makes life a little bit easier. So that's our ellipse. It's driven by the denominator who's larger. Because this is an add, sometimes they will switch the numerators and they will put the y first. Okay, and I'm not sure if in the homework I think there might be one that's switched. I have to check back. I don't know if I have one in here that's switched. No, none of them that are switched? Okay. Also, you can absolutely use any of your formulas off of this, but it's so much easier, just like with the foci and the directrix, to just use your points. It's much easier. We don't do anything else with this. We find the center, we find the foci points, and we're good to go. All right, so let's try another one. We'll go the other way now. Okay, let's complete the square. Get your x's together. And get your constant to the other side. Okay, again, the coefficient of your x right has to be 1. So you have to factor out your 4. And again, when we do your ellipses, the numbers are not going to be that large because you're just sketching them off of a basic graph. So they're not going to be that large. Can we complete this square? God bless you. What's half of 4? What's 2 squared? 4? 4. Okay. What's half of negative 2? And what's negative 1 squared?
1.
So what do I add to the other side? 4. Bring it out of this. is how I know it's not a circle. It looks like a circle if I covered the 4. But because these two coefficients are different, this has a 1, this has a 4, I know this is not a circle, this is an ellipse. It's an add, it looks like a circle, but the coefficients are not the same. So therefore, we're going to divide everybody by 16. And reduce them out. Leave them as fractions. You want them in a fraction form because that's the formula that you need to use. Okay. So which one is the major axis? 16, which is your y. So this is going to be your a squared. This is going to be your b squared. So we're going to do a equals, b equals, c equals. Excuse me, what's the value of a? If a squared is 16, what's a? 4. If b squared is 4, what's b? 2. And we're going to use c squared equals a squared minus b squared. 16 minus 4. And unfortunately, you're going to have to reduce your radicals. So this will be 4 and 3. So 2, radical 3. Not so bad when your foci is actually, you're just going off the center for your foci. So that's not as bad as that. Okay, so let's sketch. What's your center? 1, negative 2. So we're going to find 1, negative 2. And translate your axis. Now, this time your major axis is your y. Try to keep track of your center. You need to go up and down 4. So if this is 1, negative 2, and you have to go up 4, you're here. Down 4, you're here. These are your vertices. Off of the major axis is your vertices. So if I'm here at 1, negative 2, and I add 4, what will my point be? I'm at 1, negative 2. I'm going to add 4 to my y. 1, 2. Okay. Now I'm going to subtract 4 from my y. It's negative 2 minus 4. Negative 6. Okay, those are my vertices. Now we have to find your co-vertices. Your co-vertices are your b. So they go over 2. Now this is at 1. So if I have to go over 2, I'm to this side. These are my co-vertices. So keep track of your center. So if I'm at 1 and I'm adding 2, where will I be? 3, negative 2. Good. And where will the other one be? I'm at 1 and I'm subtracting 2. Negative 1, negative 2. Now I can draw my ellipse.
I'm gonna apologize for the way mine look in advance.
Oh, so do mine. Especially on this board. This board is horrible.
My little leg has been drawn.
Mm-hmm. Yeah. Now, your foci sit off your major axis. Now, because C is 2 radical 3, again, all we have to do for your foci is the y is moving, not the x. So we're going to start with 1, and we're going to do negative 2 plus or minus 2 radical 3. And we're going to put your foci. So 2 radical 3, it's a little less than 4. So let's see. So where was it? I just want to get a feel for where this is going to come out. So 2 times 1.7 will be like 3 something. So it should come right above here. Just so that you kind of get a good feel for where it will fall. And this is your ellipse. We've got your vertices, we've got your co-vertices. your axis. Yes.
Can you explain how you got 2 square root of 3 down there? I just don't understand.
Yes, we took this formula and we put your a squared minus your b squared and we got radical 12. Well, we got c is equal to 12. We took the square root and now we just have to reduce it. So it reduces to factors of 4 times 3. So this is your perfect square, 2 radical 3. Okay, I just probably did it a little too fast.
Miss Moore,
Yes,
make that.
yes. Do you have any questions?